Hello everyone, welcome back to my YouTube channel. My name is Sunny, and in this particular video we'll see the further topic with respect to this reg. So reg means what? Reg means retrieval augment generation. I already started with this reg. If you will go and check with my YouTube channel, so here you will find out the first part of this reg pipeline. I uploaded a couple of more video with respect to the different topics, so definitely you can go and check with these topic as well. And yes, if you haven't subscribed the channel so far, guys, please do it. And yeah, now let's begin with the topic. So here, guys, in the previous video I discussed about the introduction of the rag. I discussed about the rag architecture. I explained you the concept of the embedding, and I discussed about the similarity search as well. So on which basis basically you are going to find out the similar vector like dot product or cosine similarity. And I discussed the data ingestion component of this reg pipeline. Now I will discuss the further component of this reg pipeline, and then I will discuss about the advantage and disadvantage of reg and couple of many more things. And then in the next video we'll see the how we can build the reg from scratch, reg fine tuning, multimodal reg, evaluation matrices, and couple of research paper. So guys, yes, I believe you are liking the video, and definitely I'm going to record each and everything in a very detailed manner. So yeah, please go through with the content, and if you find out that yes, it is adding the value in your life, in your learning, the definite, then please subscribe the channel, and hit the like button and leave your thoughts, leave your comment. So guys, this session actually it's an extension of the previous session itself. So first, if you will check the previous session and then you will come to this particular session, then you will get the better understanding, and then you can connect each and everything in a simplest way. So let's start. So first of all, let me give you the quick overview from the previous session, and then I will start with this particular session. So here I discussed the introduction. Like in the introduction, I told you that what is a RAG. So RAG is nothing. It's a kind of architecture, the kind of system which is helping to the LLMs, right? LLMs like GPT, Gemini, Gamma, Llama 2, Mistral, to provide a better responses. If you want to know in more detail way, you can go and check with my previous video. So here is the RAG architecture, guys. So this architecture I divided into three sections. So in the first one, I in the first section actually I discuss about the ingestion, then retrieval, and then generation. So actually, I just discussed about the ingestion only in my previous video. I'm about to discuss this retrieval and the generation. And in this particular video, mainly I will focus on this retrieval because this is very important part of the RAG. Now, you can go and check with the previous video. You will get this architecture, right? So what all components we have in this architecture, and how we can divide into these three parts, each and everything basically you will get it from there itself. Now, what is the meaning of retrieval? What is the meaning of augmentation? What is the meaning of generation? So here you can see like obtaining means getting a data, and then enhancing information through the LLM. That is the meaning of augmentation. Then generation means we are going to generate a data. So this process actually it's called generation synthesis, right? Where we are going to combine the user query and the retrieval output from the database itself, and then we are going to generate a refined response. Now here, guys, you can see I discuss all about the embedding and the similarity search and all. Definitely you can check with the previous video. Then I came to this end-to-end pipeline of the RAG. So there actually I discussed the complete process. So here actually I discussed the ingestion process. So in the ingestion, basically I discuss five main points. So this ingestion process I divide into five main parts. First is a document collection, means the data collection. Second is chunking, right? The third one is what? The third one is embedding. Now the fourth one is what? Indexing. And the fifth one is what? A retriever. Okay, like databases or retriever. So along with each and every topic, I associated the links as well. So here you can see the different links. So here you can go and check with the chunking process, right? Sorry, indexing process, that which indexing you should prefer. Different type of indexing whenever you are going to store our data inside the database. Now here you can see the comparison of the vector databases. So if you are going to store the data in the vector database, then which database you need to select, right? Which database will be a best suitable database for you. So definitely you can decide by seeing this particular website, and here you will find out each and every database. Now apart from that, you can see the sentence transformer. So the sentence transformer for generating the sentence embedding. We are not going to generate the token wise embedding. We are going to generate the embedding based on the sentences. So for that, actually, we have this sentence transformer. So whatever model you can see, like Gemini embedding, OpenAI embedding, or any other embedding, they are using this sentence transformer behind that, okay, behind the model itself. Now here you can see it's like this is the particular website Vectora. So it's a database, basically Vector is a vector database. You can go and check with that also. Here you will find out this particular architecture and all. It will give you the more clear understanding. Then this I discuss about the chunking size, chunking strategy and all. So regarding each and everything, basically I shared the link. So guys, if you want to take a leverage of this particular content, so definitely you can go and check with my previous video, and the description, from the description you can download this notes. Now I know for which topic you have you came to this particular video. So here I need to discuss the retrieval process. So here in this particular video I will more focus on this retrieval part. Okay, so what is the meaning of retrieval, guys? So retrieval is very easily I can explain you. So here let's say this is my data. This data actually I'm going to be converted into the chunks. Okay, now after converting into the chunks, right? So this is my data and this is my chunks. We are going to store inside the database. So here what we are going to do, we are going to store inside the database, right? After that, what is happening, so this is my database, this one. Okay, so now what is happening, so here is a user. Let's say here is a user. Now this user is asking something, right? This user actually is asking something, is doing some query. So this query will go to this database. This is my database. Okay, and from this database, basically I'm going to collect I'm going to collect top k responses. It can be top 5, top 3, whatever. Okay, this particular responses based on what? Based on a similarity search. So here what I'm doing, so here I'm having a query, and here I'm performing the similarity search with respect to this database. Similarity search with respect to what? With respect to the database. Okay, and then what we are doing, we are going to find out the top k responses. Then I'm passing this so this responses, basically further I'm passing to the LLM along with the query, and finally we are getting the output, right? Finally what we are doing, we are generating an output. So this is the complete process. Actually this is the complete process, right? So here is my LLM. I'm passing to my LLM what I'm passing this top k responses along with this query, and we are generating the output. That's it. So guys, this process from where to where, so this process, user is querying based on the similarity search, we are going to find out the top k response. So this process actually, it is called the retriever. Now this retriever actually, we have a different procedure of this retriever. We have a different ways of retrieving the data. So here this is the basic or rack pipeline. This is the basic way. So we have a data. This data I'm going to be divide into the chunks, right? And after that, what I'm doing, I'm going to convert into embedding, and I'm going to store inside the vector database. Then my user is querying something, and based on that I'm going to collect the top 5 or top k responses, top 5, top 3, top 2, whatever, and then I'm passing to my LLM along with the query, and finally I'm generating a response. So this process actually, it is called a synthesis. Okay, now over here, guys, we have some advantage and disadvantage of this simple process. So let's try to read the advantage and disadvantage. So here I'm saying this simple process, right? It is fine for the smaller data, right? It is fine for the smaller data, but not for the bigger data. Now bigger data means what? Bigger chunks, the chunks basically which we are going to be collect from the data. Here basically we are going to collect the chunks now. So I'm talking about with respect to that chunk. Now let's see the advantage and the disadvantage, and based on that we'll try to look into the next technique, right? So we have a multiple technique. So I kept three main techniques over here. The first one was a simple, and then I will come to the next two technique. So here the advantage is simplicity and efficiency, right? It is very simple. It is very efficient also with respect to the small types. Uniformly in the data handling. Uniformly means what? So here we have a data. The same data basically we are going to we are going to convert into a chunks, and then we are going to convert into the embedding, right? So here this is my embedding. Now the same embedding basically I'm going to pass to my LLM after similarity search and all. Okay, so here you can read like in the image itself, you will find out this particular text, and just try to read the same text. Okay, the same chunks used in embedding and synthesis, right? Embedding, we are going to create our embedding from the same chunks, and we are going to pass to the LLM the same thing, same chunks. Okay, there is no such changes. So it's a unified one, right? Uniformly distributed. Now here you can see disadvantage is what? So limited contextual understanding. It's not having that much contextual understanding because I told you, right, it is better for the small chunks. If we are going to pass bigger chunks, in that case my model can mislead to me, or my model can be overfitted also, right? Then it's a potential for suboptimal response. Okay, potential for suboptimal response, I will come to this point once I will discuss the next technique. You will get to know about it, right? So here this technique, it's a basic rec technique, and it is fine for the small chunks, but it is not fine for the bigger chunk, and it is proven based on the experiment. Why? Because here basically we are going to provide a uniform information. Uniform information means what? So here I'm just I'm doing a embedding from the same chunk, and I'm that particular embedding I'm passing to the LLM, right? So some sort of a uniformity we are doing over here. Okay, now let's look into the other techniques. So here we have two more technique. This technique actually it is like better compared to the previous one, and it's a little advanced technique also, and many people are using this particular technique for creating a better reg system. So here the second technique is called sentence window retriever, small to large chunking. What is the meaning of it? Let's try to understand. So here guys we have a data, right? After the data, after collecting the data, what we are doing, we are going to convert into a chunks, right? We are going to convert into a chunks, then we are going to convert into embedding, and finally we are going to get the top k responses, and we are passing to the LLM, and finally this is the response. So this was the simple process. Now here in between this particular process we have added one more thing, right? So here whenever we are getting a chunk, whenever we are getting a like top of 5 chunk, okay, based on the similarity search or whatever, right? So here what we are doing, we are not passing directly this chunk we are not passing to my LLM. What we are doing, so we are getting a complete context of the chunk, complete context of the chunk. So again we are going to connect with our chunking, okay, and we are going to connect with our document, okay, with the chunking basically, and we are trying to find out a complete detail related to this particular chunk. Getting my point? If you are not getting, let me tell you with the example. So here guys I kept one more image because I know you won't be able to or you won't be getting. Okay, so here you can see, let's say this is my chunk basically, which is stored somewhere, where, tell me, which is stored somewhere. So here is my database, right? This one. Now wherever I'm like getting, let's say, top 3 queries, right, based on the similarity search and all. Let's say this is my user which is querying something, and I'm getting top 3 query, okay, and this is one of the query, this one. So what we are doing, so this query actually, again we are going to connect with our chunks, the original chunks. Getting my point? So this is my query, embedding lookup. This is my chunk basically, which I'm going to collect from the embedding database. This one, this particular chunk, and again we are going to collect our collection of chunk, and then this is my complete output. I can give you one more example, and with that you will clearly understand. Let's say here from my embedding, I'm just collecting my name is Sunny. So my model, so here what I'm doing, let me rewrite this particular part. So here what I'm doing, I'm writing my name is Sunny. Okay, my name is Sunny. Now here guys, instead of passing this single embedding to my model, right, what I'm doing, again I'm connecting this particular embedding with my chunk, okay, where I am having a multiple chunk. And then what I'm doing, so here basically I'm using some mathematical some mathematical concept, like similar like you can basically think, so what we are using, the similarity search, okay, just for sake of the simplicity you can take this one. And then what we are doing, so we are getting a complete text around to this particular sentence. So here the complete text is what? Let's say my name is Sunny, I'm working as a data scientist, I'm living in a Bangalore, and I'm a data scientist, or I'm like a AI engineer, or like I'm a married, I'm non-married. Complete text, and this particular text I'm going to pass to my, tell me, I'm going to pass to my LLM for generating the response. So this is the complete explanation. I think you are able to get it. Now you can read this particular theory as well, and with that simply you will be able to get it. So during retrieval, we retrieve the sentence that are most relevant to the query via similarity search. Yes, we do that, means from the vector and vector database, we are going to collect that and replace the sentence with the full surrounding context. With the full surrounding context. Using what? Using a static sentence window around the context. That is my point. Okay, so by using the context window, here I was saying a similarity search also, but this is not an embedding now. We cannot perform the similarity search. So here the main concept is what? Like a sentence window, right? So this is my sentence. So 10 words from here to here and 10 words from here to here, context window. And by using that, we can take the complete paragraph, and that one we are going to pass to the LLM. I hope you are getting that. So far we have covered two techniques, simple one and this window based one, right? Sentence window retrieval. Now let's try to discuss the third technique, which is auto merging retrieval. So what is the meaning of auto merging retrieval? Let's try to discuss that. But before that, let me tell you the advantage and disadvantage of this technique. So advantage and disadvantage is very easy to understand. So enhance specificity in retrieval, context rich synthesis, right? And balanced approach. So it is enhancing the specificity in the retrieval. Context rich means we having a lots of context, and here balance approach. So kind of balance approach means we are passing a lots of information to the LLM so that it can generate the response. Now here it is going to increase the complexity, and yes, this is true. Okay, so I hope this thing is clear. Now let's try to discuss the next technique. So here guys, in the next technique you can see, so in the next technique actually we are talking about this auto merging retriever, right? So this is one of the technique for retrieving the like embedding, or for retrieving the similar type of sentences from the database, from the vector database. Now let's try to understand this particular technique. So here what I'm saying auto merging. Okay, auto merging. So just try to focus on this word, auto merging retrieval. And here I have one chunk, right? So let's say this is my vector database. So from the vector database, what I'm doing, I have collected this particular chunk, right? And this is my another one. Okay, so from here also so here is what? Here is my another database, and this is my another chunk which I'm going to collect from here, right? Now guys, first of all, read the theory. So what I've written over here. So here I have written that auto merging retrieval aims to combine information from multiple sources or segment of text. Okay, segment of text to create multiple resources. Okay, if we have a multiple resources, let's say we have a multiple databases. This is my graph database, this is my SQL database, this is my vector database. Okay, so this three database. So from the multiple sources or segment of text, right? Segment of text means what? Tell me. So here let's say we have a one document, another document. Okay, then next document is what? Document is a sentences, right? So document is sentences, or whenever we are going to store it inside the database, so it's going to be it's going to become an embedding, right? Embedding means what? Numerical representation of the document, numerical representation of the sentence tokens. Got it? So segment of text. Okay, so multiple segment of the text to create a more comprehensive and contextual relevant response to query. This approach is particularly useful when no single document or segment fully answered. Means, let's say one document means one sentence, right? So here one document or one sentence actually, it is not able to answer, right? Whenever we are passing to the LLM along with the query. So if it is not answering to me, if it is not able to answer the query, in that case what I will do, I will connect with a multiple document, right? Multiple document. So here you can see, so what rather the answer less in combining information from multiple sources. So if you want to connect with the multiple sources, we can do that. So here let's say this is my one vector database, this is my another database, vector database, or any other database. We are going to create chunks from there, right? So here is what? Here basically from this database, this is my chunks, and we are going to connect it and we are going to merge it. Here also we are going to merge it, right? So yes, basically definitely we can do that. We can merge the chunks from the different database or from the different sources. I hope you are getting. So this technique actually, this technique also we are using for what, guys? For enhancing the generation process, right? Now here you can see I have given you the steps also. So if you want to perform this auto merging, then how we can do that? So define a hierarchy of smaller chunks linked to the parent chunks, right? So here we have one parent chunk, And related to that particular chunks, what we are going to do, we are going to define a hierarchy of the smaller chunk, right? Then if the set of smaller chunk linked to the parent chunk exceeds some threshold, right, like cosine similarity or something, then we are going to merge it. So what is the meaning of it? So here we have one bigger chunk, and we have like a small chunk. So what we are going to do, we are going to check the cosine similarity. If it is fine, okay, if this chunk is fine with respect to the similarity, if it is passing the threshold with respect to the similarity, then what we are going to do, we are going to merge that. We are going to merge all the chunks and we are going to pass it. And how we can do that? So here, from the different sources, from the different databases, we are going to collect it, or from the different document itself, we are going to collect it, right? So there are so many ways. Now here the method will finally retrieve the parent chunk for the better context. Getting my point? So here either you can pass this particular chunk, the combination of chunk, or either you can pass this one. I've seen both things. That's why I'm telling you, because I've seen the low level coding of the llama index, which I will show you in some time, right? Fine. Now here is advantage. So here we are passing the comprehensive contextual response. We are passing a bigger like a bigger chunk of the data to the LLM. Now here, reduce of fragmentation. Fragmentation means what? Fragmentation means if we are going to divide our data into the small chunk, so it is going to reduce that process. Means we are going to merge everything, and after the merging only we are going to pass it, we are going to pass to the LLM, right? So here, dynamic content integration, yes, we can do that. If we are going to merge it, so yes, we can connect as many as possible resources, and from there we can connect our data, right? We can connect our data and we can pass it. So now disadvantage wise, it's going to increase the complexity. Over generalization is there, means overfitting a problem. Computational is also expensive. So there are a couple of disadvantage also. So here we have three main technique. The first technique is a simple pipeline. The second technique is the sentence window, right? And the third technique is what? Merging technique. So we are going to merge a different chunks all together from the different resources, or from the one resources from the different document. If you are not able to get it, guys, then please try to revise this thing again. Definitely will get it. If you have any doubt, you can write it on the comment section. I will try to reply it. Great. So now, guys, coming to the next concept over here, and this is going to be a very important. So let's try to see with this particular concept. So here you can see ensemble, retrieval, and generation. Okay, then ensemble, retrieval, and re-ranking. So ensemble retrieval, I think we have already seen, means we are merging now. Merging. So merging means what? Ensemble, right? Ensembling. I think you know now, right? What is the meaning of ensembling? Ensembling means, I can give you very basic example. You know the decision tree. You are aware about the decision tree, right? So what this decision tree is doing? Tell me, if we are talking about this decision tree. So this decision tree actually, it's going to be create this decision tree is actually is going to be create a multiple hierarchy, right? From the root node to like child node, then leaf node and all. Then this decision tree, we are going to combine a multiple decision tree similar to that only. So it becomes the random forest. And this random forest actually, it's an ensemble technique, bagging, boosting, stacking, cascading, pasting. There are lots of ensemble technique we have. So here we are going to be merged, right? Multiple retrieval means what? Tell me. Multiple retrieval means what? Multiple retrieval means multiple document, multiple like a sources. Retrieval is representing a database. So we are going to ensemble, we are going to collect the data from the multiple retrieval. So one is a vector database, one is like graph, one is like a new basically SQL based database. We are going to collect from every database, okay, and then we are doing a re-ranking is one of them. So this technique actually, it is being used for the advanced rec concept, for the advanced rec concepting. So advanced rec concepting. So if you don't know about the advanced rec concept, so here, guys, let me show you one post. It's a post of the Jerry Liu. I think you know about this particular post. So this person actually, he was able to like, he is responsible for creating the llama index. I think in my introduction of the llama index also, I talked about this particular person, Jerry Liu. So this Jerry Liu is saying, if you want to create a dynamic retrieval over complex question, right? So in that case, you need to follow this three technique. I took this post from the Twitter itself. Now here you can see query generation. I think you know the query is getting generated from where? From the user side. There's ensemble retrieval. Ensemble retrieval means what? Based on the query, you can see you have collected the information from the different resources, right? let's say there is a multiple document, or with respect to that you are maintaining the multiple database, right? And let's say like you have a multiple document, and from those particular document you are maintaining the single database, anything on any level, right? So here ensemble retrieval from where? From here, from the vector database. So and then reciprocal rank fusion. So here we are like thinking about this re-ranking also. So let's try to discuss this process, and it is going to be a very important whenever you are going to create a efficient rank system, right? So ensemble retrieval means what? So here we are going to collect our responses from the different sources, from the different database, or you are going to collect our response from the single row sources, and then you are going to ensemble it, means you are going to merge it, right? That is the meaning of it. Now here let's look into this particular architecture, and the thing will be more clear to all of you. So here what we have a document. So this is a multiple document which I'm going to be stored inside the vector db. Now here is what, here is the like here is my query, this is my query. Now here I'm going to get the top 25 responses. Now here is what, here is my responses, this is my all the responses with a yellow shine. Now what we are doing after collecting these responses, what I'm doing, I'm passing to the re-ranker. And from the re-ranker, right, re-ranking means what? So here actually if I'm saying top 25 response, so here also I'm doing a ranking. Now ranking based on what? Ranking based on the similarity score, ranking based on the similarity score. Now we are not satisfied over here because there are so many responses with respect to this complex data set. So again we are doing a re-ranking, okay, based on what? Based on the similarity, based on similarity. So yes, this re-ranking is also there, and now we are deciding the top 3 responses. Means here we are optimizing the process, so if you want to create an advanced rec system, so here you can include this ensemble like retrieval. Ensemble retrieval means what? Collecting a question from the different data sources, or like you are going to collect you are going to collect queries from the database, and then you are going to merge it, then you are going to ensemble it. On any level you can relate this word ensemble retrieving, right? So here then we are passing it to my LLM. I hope this thing is clear. I have included one more architecture, and with that the theory will be more clear to you. So here is my one retrieval, means my one database. This is my second retrieval, my second database. This is my third retrieval, my third database. Okay, this one. Now here is my user query. So user query is going over here, here, and here. Then from this retrieval one, I'm going to collect these two queries. Here from here also I'm going to collect this two query, and from here also I'm going to collect this two query. Now what is the size of the what is the size of the query over here? So sorry, what is the size of the response over here? 128 tokens. 1512 tokens. Here 1024 tokens. So here I collected two responses, top two, here top two, here top two. Now we are passing this all the responses where? To the re-ranker, and again it is going to be re-ranked, and then I can get like a top 3 responses, and that top 3 responses I'm passing, this top 3 responses basically I'm passing to my LLM, and that is a simple process. That's it, nothing else. Okay, so I hope this re-ranking is also clear to all of you. So fine, I think retrieval process is clear. Now coming to the generation, guys, and let's try to finish this session. So here is response generation, means synthesis. So first I'm getting the user input. So here let's say my user, I can explain you that. Let's say here is my user. Now user is querying something which is going to the database, and here is what, here is my database. Now from this database I'm getting top of 3 responses based on what? Based on a similarity search, based on a similarity search. And here guys we have an indexing also. So with respect to this vector database we have indexing for the fast retrieval, right? And then we are passing this thing. What we are passing? We are passing this particular query plus what we are passing? We are passing this query plus what? Plus this response which I'm getting from the database to what? To my LLM. So here is what? Here is my LLM. It can be anything. It can be like Gemini or GPT or anything, and this LLM basically this will be responsible for generating the response now. So this is my whole sort of architecture, basically whole sort of a generation process, and I shown you the different database retrieval, or I shown you the different retrieval processes. I shown you the chunking. I talked about the indexing also. Everything basically, whole nitty-gritty detail basically I try to talk about in this particular architecture. Now see, so information retrieval, okay, so it's a database. Now combining data, so here I written the complete detail, then generating text, and this particular process is called reg, which is responsible for and which is responsible for accuracy and the relevant output. So in such a way, basically it's crafting out like output. So yes, definitely I'll be getting a like a trustworthy response. I hope everything is getting clear now. Now let me clear few more thing over here. Advantage and disadvantage. You can read about it, and definitely after this much of understanding, definitely you can understand about it. So here's those things which is not available inside the LLM. We are going to achieve by using the RAG. Improve relevance and accuracy. Yes, this is true. Handling open domain queries. Yes, we can handle the query with respect to any domain. Reduce generation biases means yes, definitely we are going to reduce the generation error. Multi-model capability. Yes, definitely we can manage the store. We can manage the database with respect to the images, text, anything. Yes, this is also possible. We can create any kind of we can use it for any kind of a use case, image capturing, content summarization, content generation, or content classification, anything basically. Human and AI collaboration, this is my favorite. So yes, by doing this one, we are able to perform human AI collaboration. Human is our database and AI is what? LLM. RAG does not require model retraining, saving time and computational resources. I hope you are getting it, guys. Now disadvantage wise, is having some sort of a disadvantage because this whole sort of a process depends on something. So first thing is what? Chunking. The second thing is what? Embedding. The third thing is what? Similarity, or this one, similarity and indexes, semantic meaning, or indexes. Basically I can write over here indexes, and then chunking, embedding, similarity, indexes, and then finally LLM response. So yes, definitely if anything, okay, if anything is not optimized with respect to the real time query, so definitely it might mislead to me. So here I mentioned the same thing. If look to the chain of the process of the RAG, so chunking is there, embedding is there, retrieving is there, okay, similarity search is there. This is the whole sort of a process, and yes, if it is going to be mislead somewhere, in that case it will mislead to the final information also. So please try to be careful whenever you are going to build a RAG system in the real time, guys. Got it? So for that only I have created this whole sort of a document, and definitely it will help you a lot. Now how you can create this RAG system, guys? So how you will be able to create this RAG system? So at the end I have included some framework as well. So here you can see you can create the RAG system from scratch by writing your own code in the Python itself. You can use the LangChain, you can use the llamaindex, right, for the like RAG system and all. Right now here you can see the haystacks. Okay, it's an end-to-end RAG framework for the document search provided by the DeepSet. Similar to the llamaindex, we have other framework also. Haystack is a framework, you can use that also. Realm is a framework. Retrieval-Augmented language model training is Google toolkit for open domain question answering with RAG. You can search about it. If you are going to search about the Haystacks, then definitely you will get it, and it has been completely designed for the RAG only. So it is an official website. You can definitely go and check with this Haystack, right? So here you can see it is completely designed for the RAG. Now similarly you can search about the realm as well. So here you can check about the realm RAG. So it is already available over the Hugging Face. So yes, definitely you can go and check, and yes, definitely you can do the like you can create the RAG system and all. But here my suggestion for all of you is nothing, it's a llamaindex, guys. It's a llamaindex, and yes, it is a very much useful. And don't worry, in the next class I will show you that how you can build your RAG from scratch by using the llamaindex. Yes, llamaindex code is also there along with that our own code, right? So both things basically we are going to discuss in the next session. So I hope guys you like this particular session. Now here I have included this architecture. Now let's try to understand it. So here you can see stages. I think you know the stages. Key concept of the RAG: embedding, retriever, routing. Okay, routing basically is with respect to the end-to-end applications and all, right? Indexes, connectors. Okay, nodes, documents means nothing. It's a like data itself, chunking and all. Now here you can see what for what basically we can use this RAG. So we can use for the query engine, chat engine, agents, right, for creating the agents and all. Now here you can see the complete whole sort of a process. So question is here. Now here basically what we are going to discuss, what we are going to do, we are going to translate the query means basically we are going to find out the semantic search and all. Over here you can see this one. So just try to read over here. Okay, so everything you will get, query translation and all, it is with respect to what. Then we are going to do a similar like similarity search with respect to the database and all. Now here, this is my different database. So according to the database, we have designed the routing, and then here what is happening. So yes, this is my whole sort of a document, right? And here with respect to the database, this indexing is there. So in the database, actually, we have a embedding, we have a multi presentation indexing and all. So with respect to the different like with respect to the different database, according to that, basically we'll be having indexing. Then we have a chunk optimization and all. We can create a chunks, we can split that, and we can get the best to best chunk, right? So here chunking, embedding, and indexing already I discussed. And then finally over here we have a document that we are going to pass to the basically we are going to pass to the model. Okay, now here you can see re-ranking and all, re-ranking, rank gpt, rank fusion, different model is there for the ranking also, right, for the retrieval. And then finally guys, what we are going to do, we are going to generate it. That's it. So this is the whole sort of a process. Definitely you can read more inside this architecture, and everything you will get it, because after explaining these many of things, easily you can connect each and every part. So here is the base architecture of the rag, this one. Now you can understand any sort of a architecture of the rag by seeing by understanding this lecture. Okay, by understanding this particular architecture. So here guys, this component will be more clear whenever you are going to create the applications and all. Definitely it's going to be clear, right? Now here, once you will read it carefully or slowly, each and everything you will be able to get. So llamaindex, langchain, single store, openai, these are the framework models, apis and all, which you are going to use for creating the application, okay, or this rag based stuff. So this is it guys, this is the complete end-to-end introduction of the rag pipeline. Now in the next one, in the next session, we'll go to start the practical. So guys, stay tuned with the session. If you want to build your basic rag system by using the llamaindex, here I have already recorded one project. Sorry, here I already completed one project. You can go and check. Okay, so fine guys, thank you, bye bye for for watching this video. In the next session, I will discuss about the practical. Thank you, bye bye, take care. If you haven't subscribed the channel guys, please subscribe. If you find this content is useful for you, please try to share with your friends, whoever is required this type of detailed content. Thank you guys, thank you very much.